Hello. So let's talk about some more code example, which last class we discussed about sorting algorithm like bubble sort. So similarly, let's we are going to talk one more algorithms, and after that we are going to the continue other some simple codes. So last class we have discussed whenever we have a slice array of numbers, array of integer, we can arrange the data in ascending order or descending order using these bubble sort algorithms. Bubble sort algorithm say just compare first element to the second elements. If this is the greater than, then swap the value, exchange the value from here to here. Okay. After that, again compare next element to here. If this element and this elements are interchangeable, then swap. Else compare to this, compare to this, and compare to this. In this way, whenever you complete slice, the largest element go at the end. But similarly, we can do the same activities, then second largest is found. Again do the same activity, the third largest is found. Again the same activity, then found, then found. In this way, we can arrange each and every element of a slice in the ascending order. Okay, similarly you can change the condition, it's become descending order. So today let's go one more example, and which help us to understand this arranging a number or sorting algorithms. Lots of algorithms, and the outcome is the same. You can arranging the elements in a particular order, maybe ascending, maybe descending, whatever the order. So same thing yesterday also I discussed in last class. Whenever we have a number, and you can also arrange the number in the selection sort. So let's today talk about the selection sort. Selection sort. So what selection sort say? So let's figure out, this is the first position. The first position always the smallest value of here. So we have to choose the position number 1 and find out who is the smallest, and whatever let's this is the smallest one, just interchange this value to the here and interchange this value, swap the value to here. And once you complete one layer, then you have to select the another position, next position, and what would be the right value for this position. So the next smallest, figure out everyone who is the smallest, and let's keep find out this is next is smallest, then you can replace the here. Similarly for this position, similarly for this position, similarly for those. So this is the way we are selecting one positions and figure out what is the right value for here. So you can say this is a selection sort. So let's write the example. So here function selection sort. That's a selection sort, and you receive like a array of slice of integer. Okay, so now we have a slice of integer, and you are going to arrange it. So what is the objective? We have to find out the what is the so let's simply print the every loop. So here start from 0, and this is the slice. So you can say length of your slice and I plus plus. So here if you print them, fm print them your let's min index and min value, and here print the okay. So just try to hey, this is the your every element you can at least get, and here let's create input slice. Input slice. They have created some input slice and just sort them, and after that split them. And you can say before this is only the input slice. Okay, this is the input slice, and after sorting you can sorted slice. So currently in this case we are not doing any, just printing the number. So if you run, we are able to get each and every element. So our objective, let's figure out what is the first position and figure out who is the minimum number, and minimum number, find the position and replace them. So first at least we can figure out each and every element, and after that we are going to find out who is the minimum. So let us say example, this is the first value you find and compare with all other, and you find out, hey, is there any minimum value than this one, then we can check. So let's do. So here let us start from the, already we started from this 1 0. So you are getting the 0 position value, you can start 0 plus 1. Okay, and after that we can check. So whatever the this new value is really less than this is the minimum value. If really yes, then just change the value. You can say, hey, now this is the your minimum value and this is the minimum index, whatever the index. Okay, and once you done, once you complete your loop, then you can find, hey, this is the your mean value and mean index, and whatever the your actual mean and index value, you can swap them. Okay, so what are here objective? First you get the first position value. This is the first position value, value and index. This is the value and index you figure out, and from here +1 from next one, yeah, from this position you compare this position value, next value is the minimum, then this one no, then this, then this, then this, then this. Let's keep figure out, find out this is the minimum value, then we note ki what is the value or just what is the minimum position. You already know the position, then we can simply switch from here to here. So even you just need a index, which index have a smallest value, you can just swap from there to here to here. This is the just simply you can do, right? So here notice you can print each and every value and index, value and index. Here once you find, hey, this is the my minimum, and just simply we can do it, hey, I find this is the minimum index and that is not than the same, that is not the same, then what is can, hey, this index, what is the value, and replace this this value, mean index, and from the mean index again replace the original value. Last class we discussed how Go language support the smartest way to swap to array positions or the value without using the third variable, just the concept. So in this way you are able to, first you figure out what is the mean value. So instead of everyone and this one, you can say, just I'm remove it just for your understanding, and here this is the mean index and this is the mean value, and you are just checking, hey, what are the finding the minimum value starting from here. If any less than this, you can just note them, and once you find out the every element, and then you can say, hey, just swap them. This is the swapping, the interchanging the minimum position. So at the first position you can find out the minimum, and similarly for the next, and then next. So let's run it. So here you notice I am doing couple of things. This is the your top array, okay, and this loops are is starting from first position. That is the first position index and value. And this loop say, hey, I am running another loop from +1. Means if you are selecting this position, I can start it from loop to this to last, and find out any value, this value, this value, this value, this value, any value is less than my selected position value, this value. Okay, then I note this value. Hey, this index is the minimum value. I noted this minimum index. So might be end of the loop you find, hey, this is the minimum index value. So you can find. Okay, here you just check. Yeah, might be case there is no minimum. There is no minimum. Then there is no case of your swapping, because this is the already minimum. Might be case. So here just check. Hey, minimum index not equal to our initial index. Then that means that somehow we find out another index which is the minimum than the selected index. Then what is it? Just interchange the value, change, so swap here, this value swap here. So this is your interchanging swapping value. This is the finding the minimum index where the value is the minimum, and this is the for the position. This is the first position. Once this done, then similarly we can do for the next position. Next position found any minimum, yes, replace them. With third position, fourth position, fifth. The first loop say, hey, I'm going to select the position, first position, second position, third position, and this loop say, hey, finding the minimum after that, any minimum. Second, hey, if found minimum, then interchange. So let's look the output. So notice here we have a found, this is the my original element, this is the my sorted element. So who first I pick up the, this is the my let's run the dry run. Same example, like here 5, your 3, 6, 2 and 10. We selected the first position. Let's say selected the first position. Okay, here check from this, is there any minimum value? 3 minimum, yes. Okay, just go, let's 3 minimum. Then after, is this 3 is any other minimum? No, not minimum. 3 is more minimum than 3. Okay, note this one, this one, any minimum? No. So this is the minimum place. So what you do, just we swap this value, first position 2, and this is the 5, and again third and 6 is the same. So now we know first position is the selected is the right. Now move to the second position. This is the second position 3, and just check 3 is the minimum, is there a minimum? No minimum. That means 3 is the right place, no swap. Next, figure out the 6. Selecting the next position 6. Any minimum? Yes, minimum. Just swap them. This is the 5, this is the 6, this is the 10, and now it's already 2, already 3. Already I've selected this, already selected this, selected now 6. 6. Any minimum? No minimum. Leave them. Next time select 10. Any minimum? Already last element no. So that is this is the sorted element. So in this way you can do the sorting of the input. So you can say, let's these just do the some exercise the way where we are manipulating, changing, replacing the value within a slice. And for very good example here, slice help us to supporting this sorting algorithm. And surely lots of sorting algorithms. I'm not going to cover each and everything. Maybe here we cover the bubble sort, selection sort, insertion sort, heap sort, merge sort, quick sort, redis sort. Lots of sorting algorithm data structure support. And each day sorting have a different kind of pros and cons, the approaches, the algorithm, the way data structure defined. So surely you can do practice all other things, depend upon the nature of our applications. Different some where we are going to the merge sort, some we are going to the quick sort, somewhere we are going to selection sort. Each sorting have a different approach. The final outcome whatever the your number, they are going to arrange in a specific order, maybe in ascending order or maybe descending order. Okay, so here maybe notice by default sorting order means ascending order. You want to descending order, selection sort for descending order, just you have to change this is the mean value to the max value. You take the max index, max value, and just change the value. This is a condition change, and after that you are getting the maximum index. So we will do practice for the ascending or descending order for index. Good. So hope it's help for maybe this your assignment. Let's you try to write some selection sort algorithm, merge sort algorithm, quick sort algorithm, lots of sorting. Just Google it. What is the bubble sort? And whatever I am talking here about the selection sort, bubble sort, you can just Google what is the. If you don't know the data structure, just go Google. Hey, I want to know the approach, how the bubble sort works, how the selection sort works. Okay, and just like selection sort. Okay. Selection sort, just run, and here by default you are getting the concept how selection sorts are implemented, and just with read the theory here. This is the selection sort, and this is the concept we have mentioned. Hey, this is the first position, then second, then fourth, and finally we have whatever the number here making one selection sort. Like here mentioned selection. This is the code also here given. This is some arranging, some implementation code also we found here. Like here notice this is the different language, like basic C language. Here find out the minimum position, looking to find any minimum, find out the minimum, and just swap them value. For swapping have a different functions in the C language, but objective is that you can find might be this is the different language how to implement the same which we did, and similarly for others. Okay, so if any data structure whatever you want, just go and read. Notice that this is lots of data structure: exchange sort, selection sort, insertion sort, merge sort, distribution sort, concurrent sort, hybrid sort, and in this select insertion sort, lots of sorting algorithm for insertion sort. Similarly, like other types of sorting. So you can say find out lots of sorting algorithms, but surely we have not covered each and everything. But surely whatever you need, you can just read out the concept and try to implement any programming language. Data structures are the subject which are neutral to the programming language. All the algorithms of the sorting you can implement maybe Go language, C language, C++ language, data structure, Python, Ruby, Kotlin, JavaScript even. Okay, so lots of programming languages, some support data structure, some you can implement. Okay, so good. So let's go some more example here. So notice here we have already covered how we can use the array data structures and slice. Okay, so here is a concept. Whenever you have created the slice of byte, in a GoLang, it's let's here like a slice of integer, maybe slice of int, slice of byte, a slice of something, slice of string. So in the Go language, you can say slice of byte. Okay, so slice of byte in Go language is a string. Okay, so here maybe simply say, hey, name. Okay, even you can say name slice. So here is the name of slice. Even one name, say, hey, name equal to cat or something. So notice this is also a kind of a slice, because notice here character 1, character 2, character 3. So here in the Go language we are not using this simple character, but rune 1, rune 2, rune 3. So even slice is not just work for an integer, even it's work for decimal, float, bool, even a string. And what is a string? Logically, a string is a sequence of character. Okay, sequence of character. Yes. And even this string you can make a slice, maybe strings of some zebra, apple, banana, cat, dogs, anything name can be. So you can say the this slice just not restrict for the number system, even for any kind of value, maybe rune, maybe decimal, maybe float, maybe number, anything, maybe string, maybe later part we're going to discuss about the custom object like struct or interfaces. You can create the array and the slice. Okay, so it's okay. So let's so even sometime you can do lots of permutation combination on a string. So here say like name equal to GoLang. Okay, this is the name. So in this name, every character or every rune you can also interchange, print, whatever you are doing like here. Similarly here, this is a not like one variable, but GoLang, you can say it's a standard string class or a string object, a string library. And but internally this you can say, hey, maybe for loop, even you can say for let's index comma character equal to range, you can say range name. Okay, and here you can say print. So even let's I commented everything here. So what I'm trying to say, somewhere here is no syntax like you notice the array or slice. Even the GoLang will support internally, GoLang will understand this is the sequence of character, and sequence of character look like our array or slice internally. Okay, so please note that good example inbuilt by default your string in okay is internally implemented using this array data structures or slice. And even you can find out every index, every positions, you can replace value, you can arrange value, you can change value, you can order them, you can reverse them, lots of permutation, even small example you can write them. Okay, okay. Yeah, notice here what I am getting the value here. This is the index 0, 71, index 1, what this. So internally this GoLang is the one string object, but this is the 0 position value, this is the 1 position value, this is 2 position index, this is the all are the our indexes, all are the index. And what is this? This is the ASCII value. If you check the ASCII value of 70 is the capital G, ASCII value of 111 is the O, ASCII value of 108, this is the L, ASCII value of 97 a small a. Let's check. So notice these are the in Google ASCII table. You can figure out, hey, this is the ASCII table. So here notice all are the Unicode characters. So here notice here I am fitting 71. What is the 71? Let's check 71. Is 71 the capital G? So this is the capital G. What is the O? 111. Let's 111. This is the 111. Notice this small letter O. Similarly 108 is small letter L. 108 is small letter L, right? And similarly 97 is small letter A. 97 is small letter A. So generally, if you notice here, these are the some remember things. All our lowercase start from your A alphabet 97 and to small z 122. So you can say greater than 97 and 2 122 is the small letter 1 to z, and similarly capital letter 65 to your 90. So capital letter 90, 65 to 90. Sometime you have to memorize. If you are getting any ASCII value greater than 65 until 190, that is the capital letter. From 97 to 122 is the small letter, and similarly you can say space is the 32. All the number start from the your 0 to 9 start from the 48, 49, 50, and these are the ASCII value. So each printable character have some unique code, and that's code known as a ASCII code. Okay, good. So somehow if you want to interchange, let's say I want to change this small letter to capital letter. So you know small letter A ASCII value is the 97. I want to convert a capital letter, let's A. Capital letter, we know the ASCII value is the 65. If you notice, what is the differences here? If you just minus this and you find 2 and 3, if 32 is differences, means any character you want to convert, so just here minus 32, you are getting the 65 become a capital letter. So somehow if you want to convert lowercase to uppercase, just do minus 32. If you want to convert, let's say this is the 72, I want to convert a capital letter 72, you want to in small letter, just plus 32, and you find 4102 is your small letter H. So sometimes this mathematically help us to converting any lowercase to uppercase or finding. So in this string you can say manipulations, lots of you can say tricks happen. Okay? So here you can do. Okay? So if I want to print the corresponding the value, so here you can say comma, this is the index, okay, this is the index, and comma, this is the ASCII value, and this is the actual value or character. Okay, and if okay, and you just print. So somehow you want to get you can say different permutation combinations, lots of here in this case or string you can do manipulations. So here look like here internally Go language implemented for string as a array data structures arrow here everything, because notice here range 1 for our array data structures are slices, and here they return the index and return the your actual character or actual value, and here somehow okay. Okay, so sometime even you want to conversion is small to lower to upper, you can do. So notice here we can find the complete, hey, this is the index 0, This is the ASCII value 17. What is the express character? GOL. Let's say I want to convert this complete in the capital letter or complete in the lower letter. We can do, just modify them. Okay, just change them. So let's here say go. Okay, and I want to, this is by default they print all the lowercase. I want to print even all the uppercase. So how can do? You know, already we know though. Hey, let's convert to uppercase. Convert to uppercase. To uppercase. Okay. So we know already whatever the string value, if you minus them 32, and it will become a converted your uppercase. So each character, whatever the character, this is the lower character in the lower case, in lower case, lowercase c, we just pick up C. I want to convert to uppercase, just minus 32, and you just want to print the not ASCII value, you want to print the string, and you can do. So lots of permutation, combination. Someone say, hey, maybe instead of this loop printing each character, someone maybe, hey, you can write the function. This is the my one what the name or any string, can you convert to the lowercase, can you convert to the uppercase? Surely we can do. We can write the function, because we know internally this is a look like array data structure, and here we can do lots of manipulations. So let's so notice here your complete index, the ASCII value, and here your character in lowercase like GOLH and corresponding capital letter. Notice all are the capital letter. So conversion from you can say here lowercase to uppercase, just minus 32 from its ASCII value. And if you want to convert again back lowercase uppercase to lowercase, just a plus 32, you are getting the logically. So let us going to write the function. Hey, write the function to convert input string to the lowercase or input string to the uppercase. Okay, so here you can say, hey, I am going to just comment them. I am going to write a function to uppercase to uppercase. Okay, to uppercase, they receive the, let's any value, maybe a string or a string, here name. Okay, input, whatever the input is string, and also return a string. Okay, so here you are going to write one function that take input string and return to uppercase of this string. Okay, so you can write the code. And what is the code? Here say, hey, let's say start model, whatever the input string, this is my value. I know I want to convert, so whatever the, I'm just create one string variable, I'm just going to appending by default string have also one operation append plus, like because internally notice why this plus operator here support, because strings are each and every value are you can say internally your integer ASCII value as integer code. So here maybe we can say uppercase, upper to upper, the result, this is a variable types string, and you can take one input and just minus 32 and note them, plus them, and finally you return the results. You can write this way, or simply you can write say plus. Okay, so here, so this is the small function you can test here. Hey, to uppercase, and just take to upper case, upper to upper. Okay. In this way, you can just converting. Hey, this is my input. Maybe here you can say hey, to lower, lower. We have a lower variable. Okay, lower variable and converting to upper. Okay, so here we can write our own function that pass any lower input, and they can convert into the upper using your range function. I know this is the internally used slice. You can loop them and run. So similarly, you can write another function. Hey, for similarly like toUpper, similarly you can write the toLower function. So similarly, lots of permutation combination you can write here, like to lowercase, and here take input, just return. Here do just change your plus 32, and so this function become look like a uppercase. Why? Just we know the ASCII value of your uppercase is higher 65, like in the case of a 65, a is the 65, and you can convert to the lower. That means we have to just plus 32, it's become a 97. It's a so why we are able to perform the concatenation plus, because string class, string object is library, you can say. We'll talk about as well. So library, all this function written to us. So before we are going to use the library, we should know how these library are built, or library are already written. Okay, so let's again run, and even here you can say similar kind of maybe another function you can say. Just use the toLower, and this is the call them the toLower. Okay, and this is the toUpper. Here you pass the toUpper. This is whatever the toUpper, you can pass toUpper, they convert again toLower. Okay, toLower. So whatever you have input here, say input I the toLower, I input pass toLower, and output toUpper fmt. And similarly here just input whatever our input. This is the what I am doing, I'm something wrong. toUpper, this is the toUpper, copy paste somehow this toUpper. This is the passing the toUpper and getting a toLower. Input toUpper, and output you can say toUpper toLower. Somehow our mouse is not working, so let's check first what the kind of so here we have a import format. Okay, so I need an import format, and we just toLower, and just after that input printing, calling the toUppercase, and we have to pass this toLower as a input. I pass toLower as a input. I am getting the output a toUpper. Maybe I already have a toUpper. I pass the function toLower, return the toLower, and print the toLower. So here we have our own custom function, and here you can loop them, iterate them, and getting the plus for 32, minus 32. So here you can just run this. So you can say on the string, you can write so lots of, and in the string, you can say many programs. Someone asks, hey, you can convert to lowercase to uppercase, or find out all the vowel, find out the consonant, or just find out the number of spaces, split them. So lots of programs someone can ask you on the basis of this string manipulations. And good part, I'm not saying you should only use the write your own custom function, but string, notice this is a GoLang library, standard library. Ali provided this function to us, everyone. So we can use the library. Of course, in the application, we are not writing this small function to converting to upper, converting to lower, counting vowel, counting character, counting the length, right? So I'm not writing this function in the real application, but why we are doing here, our objective, we have to learn how small library function are written. In some cases, whenever we are working on a real application, and notice here output, our output, hey, here my input lowercase, I am getting output to uppercase. Here our input uppercase, I am getting the to lowercase. Okay, so in this way, lots of a small function you can write. Even you can just read out the standard library of a string and just Google, hey, you can use them. Go package, go package, go package. That's a string. Okay, so here you can find the complete string package. The string is the by default, because string is a heavily used the standard library in the almost in every programming language. And notice this is the package string implement the simple function, and this all of function like here clone, compare, contents, count, cut, lots of function, fill, index any, join, lots of functions there. Notice here to lowercase, to title, to uppercase, which we are writing in the function already. Standard library given, even you don't write them. Okay, so to lowercase. So here we return our function, but similarly already function available. Notice here I want to, this is a string object, so even this is the my custom output. Even you can directly write the using the custom library. Here say from library, and simply say, hey, a strings dot to upper. Okay, and they convert to upper. Okay, in this way, this is the existing function. Okay, similarly you can write so from here as well as, even you don't need, right? Okay, from a standard library. The string class already given us to this toLower and toUpper function. Here we can return my own, but we can directly use. But here let's import this string library. Whenever you are using any library, you have to use the import. We are in the to library, fmt for printing or formatting. Strings are using this function like hey, I need the toUpper, toLower. Okay, so here just for your references, lots of this string library given answer function. So just whenever you are going to do any kind of string manipulation, just let's check what the kind of a library already provided this function to us. And here you can read out each and every definition, what this, what that, every meaning we have to find out. Okay? Like you want to find the count, find the length, find the indexes, each and everything, a specific index character you want. So here lots of functions, somehow trim function, you want to remove the space from the left trim, right trim, toUpper, or similarly maybe join, maybe array of string I want to join with a comma or a specific characters, we can do. Okay, so preferences, whenever we are going to use, notice here this is our custom code, this is the existing library, this is our custom code from the existing library. So in the you can say basic rule, whenever we are going to write the production code, generally prefer use the standard library. But we are learning here, so we have to understand how these library are custom functions we can write myself as well as. Okay, so here you can, so why we discuss here, let's in the coming many classes we are going to use this standard library. Okay, let's same thing, I want to maybe format fmt format dot println, and whatever the our string object, and I say hey dot and toLower, even you can call this way. Okay, or even you want to say hey no I want to say string dot toLower. Okay, and these are the way you can call these methods. In this way you can call, or you can say no, already we have an object, so this already have a variable. Okay, and you can say hey dot to lower cases or to lower to upper. Okay, so this is the your string class. In this way you can call. Okay, you can call, or already we have an object, you can call this way. So different way you can use this library. What library say? Something missing here, we call. Okay, here we missing this. This should be here. This should be, let's it to uppercase. So this is the preferable way. Here we mentioned that hey, this is my string library and they have a to uppercase, and if pass the input they return the value. But generally always feel prefer using this class, but this is also have a option, but generally we are not sometime you can use, but preferable way always use the library name and plus your functions, you can say. Okay, so this is the way you can do. Okay, let's close them. So here these are the things you can do using this standard library. Please read out this standard library. Any standard library you are going to use, you have to first import here, and after import you can just read out the documentation and what kind of a function method they provided, you can use them, right? You can use them like a toLower, toUpper, lots of function here you have, like a trim. So trim is just trimming your space from the left trim, right trim, or some prefix, lots of option. Trim spaces only, you can use trim spaces. So lots of functions this string library already provided us, so those manipulation you can use by the string library. So sometime whenever you are writing a code, and maybe you have a option like this way. So let us write a function like function C, and let's uh, want to call like a sum, just for example, sum. And here maybe generally we have a 1 comma 2 variable. Let's say I want to 3 variable sum. So I'm going to say, hey, I want to 3 variable sum, like this way. You can say a, b, comma c, maybe plus c, okay, plus c somehow, okay. So sometime notice here, due to this only one specific variable, you have to define the multiple, maybe some 1, some maybe some 1, maybe some 2 digit, some it's 2 digit, and here say sum of 3 digit, sum of 3 digit. Maybe you can write the sum of 4 digits, right? In this way, multiple function 4 digits, right? A, B, C, D. Okay, D plus D digits. Okay, digits. But sometime notice here already we know the array. Instead of that, you can say, hey, we can write function like, hey, not in this way. I can write function, hey, sum, just using inputs array, input slice, input slice. Here say input slice. So here we already know, hey, I'm not going to say, hey, our whatever the your input, here you can say slice. In this way we can also do it, and okay, and write our slice logics. Okay, here say some variable, and just declare the loop and sum the value and return the value. Okay, and here sum. This is already we run. So instead of writing the 2 variable, 3 variable, 4 variable, let's use the sum using the slice. And even we know this methods take the slice. This is the way, but sometime we have another option. Hey, sum of function sum of numbers, sum of numbers. Okay, numbers just, and here say a variable dot input and return input. Okay, so in this way you can also say kind of a variable argument. So you can write this way, or you can write the variable argument number of. So you can generally, if your variable argument, the last parameter, you can always say dot 3 dot. So look like internally it's become a converted as your array. And similarly, like here one syntax. So sometime you look the code in the library or your project basis, someone write the like whenever last parameter, you can call dot 3 dot, and it's become a look like a your array. Internally same code like some integer, and range the loop and plus them and return the value. So you are calling this or this, maybe, hey, so let's just I comment out everything here, and you can use. So here say, you can say sum of, you can call here 1 2 3 4 5, and you can get the output this way. Okay, even the same this you can call, but you cannot call same as this. So let's say I want to call this sum of slice, so you have to pass this input array, and that's okay, print them. So you can, this help us to the customer maybe called 2 digit, 1 digit, 3 digit, even though they not need to specify this as slice array. So this variable argument input, you can say here any number of variable 1, 2, 3, 4, just pass here 2 digit, 5 digit, 6 digit, 7 digit. It's a take input. So sometime while writing code, maybe you can use this slice. It's okay, or array, it's okay, but this syntax only have a problem. Customer always, whenever someone going to the call, they need a kind of one slice. Okay, but sometime I need the our input is the last parameter, and we can say the variable argument. But somehow you have to write code like this. Here we not specify any 1, 2, 3 this syntax, because I know this is the function is take input argument variable, maybe 2 length, 3 length, 4, 5, 6, 7, 8, 10. Internally this become a converted as a your input array or slice. Okay, so sometime these are the some handy syntax which a Go language support. We should know this is the kind of variable argument function. Okay, so these all internally related to the data structures. Array and slice internally is treated as a array. Similarly, we discussed like a string internally treated as a array data structure, a slice data structure. Okay, so objective is that here whatever the data structure we learn, slice the array, many different way they in a Go language we are using. Okay, so don't only think our syntax like this, then we are using the array or slice data structure. No, this is the declaration. This is by default clear nature. Say, hey, this is the array data. Somewhere internally, like a string in this case, our Go library, Go language internally support, internally implemented. This is as a array data structures or slice data structure. Similarly, if you calling like this function, look like, hey, this is a function which this take 1, 2, 3, 4, 5 argument. Even might be you are right. You can write this just for the maybe, hey, no, I this call for just like a more argument. Okay, 6, 7, 8. Okay, 6, 7, 8. Okay, maybe you can say no, this might be I want for just maybe only first last 3, this one. Okay, so you can say this function look like using the simple number of argument variable, but internally our compiler are treated as a end argument array data structure internally there, because here we are using the range function, range iterating your array data structure over the number of elements and doing the sum. Okay, so notice here you are getting the sum of. So these are some kind of a different flavor, you can say, our Go language support. And even you can say one more syntax. Let us here this is the my input array. Okay, till now notice we have understand this my function take multiple inputs and return only one input. What happen? I'm my input method can return multiple value or array. Yes, we can return, our method can returns array, method can return 1 value, 2 value, 3 value as well. So sometime, hey, you can say like function let's return max and min. Okay, max and min, both max and min. Find max and min of let's I say input. Let's we have a slice of integer. Okay, and here I want to return 2 value, maximum as well as the minimum. Okay, so in this case here you can here say 1x and another x. Here you can say, oh sorry, another integer, another integer. You can calculate, you can say one write a function take input can return two value. Here you can say, hey, I say one variable max integer, and one variable you can say min, and you can say return. And here you can say max comma min, in this way. And here you can write the logic to calculate your maximum element and minimum elements. Okay, so for here you can, let's say start with there. Let's say start with here say max start with the input first element, and start loop I equal to 1 semicolon I less than length of your input, and here say I plus plus, or even you can say range, whatever. So, and here say if max is still is less than our input of I, input of I, okay, input of I, then you can say, hey, max equal to input of I. Okay, so this is the way you can calculate the max, and similarly same you can calculate for the min. Okay, calculate for your min. Here you can say min. Let's say min is the still greater than, then you can say change the min and return this way. So objective here that your function can possibly return the max and min. Okay, and here say so somehow you have a your method not return only one value, similarly 1 comma 2 comma 3 comma 4, or you can return the array of integer. So your function is a very kind of a dynamic nature. Take input dynamic, return the dynamic, return one variable, return two variable, any number of value you can returns. Okay, and even you can just call them, find what happened, find max and min, and pass any input slice, and you can get the two value. Okay, so here you can just say print them fmt directly, and fmt dot print. Okay, so here this is the function. Now they return two value, not just only one value, just return the two value. This will return. So sometime you have to so here I'm trying to say, whenever I'm using the data structure array, and we are using this like a slice or array data structure, Somehow you manually specify this array and use them, that's also. But many libraries like a string library using this internally array registers. Similarly, like our function terms sometimes look like they are calling the multiple parameter. But if this multiple parameter can be dynamic variable argument, they, yeah, Variadic, you can say, argument that will return internally work as a array register. Similarly, might be your function can return maybe just one value, maybe two value, maybe option they can returns the function function find 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 all even numbers. And here, and you can notice here we are going to return array of integer. So our function take input array as well array and return output as array. So here we are finding the all the value if modulo range 2, just using the slice append function and returning the all the slice. So call find all even numbers. So depend upon your requirement. Sometime you are writing a function and then take just input one argument, two argument, like here we started like our math, two argument, three argument, four argument, or even say, hey, our method can return the any number of argument using the variable argument. Or you can say, no, I have a specific, no, method will take your specific integer array integer, one array or slice data structure. Sometime, no, return value similar, return maybe one value, or return maybe your method can return a two value, or maybe your method can return the array of integers. So so data structures like here many places, somehow in program directly it's visible and somehow it's not visible. Okay. Okay, and just print them. Okay, so here we are using. So let's do lots of practice. Our Go language function, you can say, support many inbuilt concept like our input can be support one argument, two argument, three argument, variable argument, and are the array data structure itself, or slice itself. Similarly, for output here, output can be one argument, output can be two argument, output can be three argument, output can be array of data structures. Okay, so whenever we are writing the code, writing the program according to the, you can say, our need, sometime we are going to declare our function with a different nature. Sometime our function look like a taking different argument, variable argument, input array argument, or similarly output maybe no output, maybe one argument, maybe two argument, maybe array of integer argument. So everything while writing our Go functions support, and this is the very kind of a handy nature. Many other programming language might be not support like this syntax, like one argument, two argument as a, many language support like array, many this tuple, somehow say tuple concept supporting tuple of two argument, three argument. GoLang say, hey, don't worry, just specify the two integer float integer, you can do and get the proper outputs. So Go language support many flexible way, you can say, writing the code and testing and supporting the dynamics nature. Okay, somehow I written the mistakes where I'm missing the, this is the return. Okay. Okay. That's it will solve. Okay, so let's do practice, and now you can say maybe I'm going to give some more library example. You can say the like our string library, similarly for specifically for like array data structures as slice. We are generally not in a real application, whenever we are not directly using this slice in syntax or the array syntax. Instead we are using the inbuilt library. Okay, so maybe I'm in coming classes I'm giving some more couple of standard library exam where you can create data, manage data, add data, retrieve data, get data, and lots of other function like a sorting function, compare function, copy function, everything by default our string library, sorry, our Go language standard library support to us. Just we should aware, hey, this is the existing library exist. So before we are our objective is not just going to use the direct library, but we should know how library is. Somehow we need the write the custom code, custom function that help us to. Okay, what say line number 76, expected comma, line number 76, 76. What say this? 76. Google functions, where are Variadic functions, variable argument. We have to support like here. You see the any function you can say that some more support the multiple argument, like here value argument. We can do like similarly function return multiple value. Your function can return the multiple value. This is just comma separated, not liquid this. Okay. So here you can just write the comma this. They understand this is the first go to the here and second go to the here. Okay. And while declaration, here we require this parenthesis. Here required parenthesis, return value not required parenthesis. Now let's test them. So today we have covered many some basic things about this data structures like sorting, selection sort, bubble sort, and by default our some library like a very mostly commonly used library string are using internally array data structures to manipulate, to modify, to get. Lots of string library also have a function like append, like concat, like toUpper, toLower, toSpell. Find out even small function you can also write by your own library as well as. Okay, so notice here we have get all the, like here notice here two value like maximum and minimum, here only even number. So okay, this function return multiple value, this function take a return the array of the value, this function return only one value, only one value, but maybe input maybe 5 argument, maybe input maybe 10 argument, input only 3 argument, or input why not just array. So depend upon your the function, the method you are writing, accordingly it works. So let's do these couple of practice of this, and we will continue explore more some library and some function. Actually we can not cover each and every code example, but here our objective is that you will explore, you should aware ki how small functions are using the for loop, array, variable, if else conditions, how we are using the append function on the variable like this. So the way you are writing the number of code, number of functions, it give, you can say, a better understanding. You feel familiar with the syntax of semantic in the Go language. Okay, so let's do practice, and we'll continue some more topics, some more library, instead of just using this standard you can say like this and a test slice array data structure. No, even for this we are going to use the standard library, like a string is the standard library. Similarly, we are going to use the standard library for this array data structures, and that's a very nice. Generally in our application we are using the standard library. Why use the standard library? Standard library are tested and used by the many applications, and they have written a lots of function to us, and those functions we can easily use. Sometimes those as per our requirement there is a no such function exist, we can write our own functions, and due to that I am saying, hey, learns how we can write own function. Okay, finding all number, finding even number, everything. Here we are finding all even numbers. This might take input array and return output array. Okay. Sometimes take input array, return only 2 value. Sometimes we take input maybe number of argument, we 1 2 3, return only 1 value or 2 value, 3 value. So depend upon the, you should aware how we can write the different function, my own function as a library written to us. Okay, so hope this information helpful for you, this code helpful for you. You can also write beyond this exercise. You can do your own couple of exercise. Any doubt, any confusion, surely we have to talk. But for the related strings, you have to do lots of exercise. Like here we just say, hey, this is the, we written my custom function, 2 uppercase, 2 lowercase. Similarly, you have to write a function. I find out the any vowel in this strings or any consonant in this string, find all the vowel, find the count the vowel, maybe I also found all the occurrence of particular a specific character. So lots of couple of questions you can do here. You can just on the string manipulation, those exercise to build confident, hey, I can do lots of manipulations on the array data structure. Internally we are using the array data structure string, or you can say internally it is the like a slice of a byte. Okay, slice of byte. Okay, okay, this is a slice of byte, you can say, or just say string, or you can say just sequence of character. So here say maybe character, but in the Go language we are not using a specific character words. You can say, hey, rune. Okay, so maybe sequence of rune, or you can say here you can say sequence of rune. Okay. So both are this you can say. Okay, can do. So let's do couple of more. You do couple of more example in the, on the string manipulation, and we will continue. If you want any specific example, I'll take, surely we'll discuss and talk. Okay, so let's do the practice and write the code. Do practice. Any doubt, any confusion, please let us know so that I can talk those points as well as, and we'll continue understand more library and more concept in the Go programming language. Thank you for watching this.